Alright, I'm back with part 2 of my Crack Me, basic Linux, or reversing under using Linux. Um, Now just quickly summarize or go over what we did in part 1. We wrote a very simple protection scheme. If you remember, we called it login.c, and all it is it'll ask you for a password. It uses fgets to then read your password in. It then compares it to power, and if it's not power, you're denied. If it is power, you're authorized. Pretty simple. Let's compile it just so you can see what it looks like again. Go like this. Hello, access denied. Go like that. Power, authorized. Now, if you remember, what we did was we used GDB, the GNU debugger, to actually crack or circumvent this protection. So what we did was we debugged it, a quick breakpoint on fgets. If you remember, that's the function we use to actually read in our password. Now the reason we put a breakpoint there is we want the debugger to actually stop execution once it gets to the point where it's going to read our password in, because then we want to go into the code and see exactly what it's doing with our password. So we put a breakpoint, we run it, hits the breakpoint. Now we don't want to look at the internals of fgets. We want to step out of that to get back into the code after fgets returns. So after it's read our password, that's what we want to see. We want to see what it does with our password. So we'll step out of it, put a password in, we'll put some garbage, it doesn't really matter. That's the wrong password, so we need to know. Now we're back into main, so we should be ready for the fgets call. So we're going to do a disassemble on the instruction pointer. Again, remember the instruction pointer essentially just points to the next instruction to be executed. So we'll see here the arrow. It's right after the fgets, that's where we are right now. Now, if you remember, what we did was we basically just took a look at the code and we've seen the string compare call. Again, we've got to be of the mindset that we didn't actually write this code. We've got to pretend that we only have the binary, but what would the programmer do? Well, in this case, if we know he's reading in a string, then a string compare right after the fgets, it's pretty obvious that that's what he's comparing our string to the actual password. So that's where we look into what we can do to actually circumvent that. And what we actually decided to do was this conditional jump here. Again, this is a test. So jump if not equal. The test EAX jump not equal. Now what happens is, if it's not equal, it jumps into the bad flow of the program. So it'll say access denied. But if you don't take that jump, you're into the good flow of the program where it says access authorized. So what we did was we just made sure that that jump didn't even happen. What we did was we did what I call, we knopped it out. So we used no operation, 2 nops to nop it out. Now remember, we had to use 2 because nop is a single byte instruction, 0x90, and if you remember, this conditional call is 2 bytes, 114 to 116. You see the difference of 2 bytes. So we can't just replace it with 1 nop because the code won't align properly. We've got to replace it with 2 bytes. Now remember how we did that was something like this. Oops. Six, 7, 8. That's 1 byte. Now remember, we got to set to both bytes, so it's 2 byte instruction we're going to knock out. Really quickly, we'll disassemble again, make sure the change is there. It is. And now if you run the program, now we put the bad password in, so generally it should say access denied. But because we knocked out that jump, it's going to always say it's valid. And we're going to go into the good execution flow that we want. And then you can see it's authorized. Alright, now, so we get out of the GDB. Now we're going to run our login program. Put in a bad password. Still says access denied. Now this is because the changes we made in GDB aren't persistent on the disk. We're not actually writing those out to disk. That's just in memory in the debugger. So now what I'm going to show you today, what this part 2 is about, is how to actually make persistent changes. Write your patch to the disk for a binary. So let's call it patch.c. All we need for includes is standard IO. It's not a capital. Really quickly, go like that. Gonna go char nop equals 0x90, 0x90. So 2 nops. Remember, we need 2 bytes. And again, remember, 0x90 is nop, no operation. That's what we're gonna write over that conditional jump. Now we're going to need to open up the file. So we need a file pointer. Fopen is file open. We're going to open up the login file. It's in our current working directory. Otherwise, you could go like this, or if it's in bin, you could put the full full path, but we know ours in the working directory, current working directory. We want to open it with RB plus. So what RB plus is it'll open the file for reading and writing, and it will set the file pointer to the beginning, I believe. Let's just double check real quick. I should always check your man pages. So what I'm doing is man fopen. If you're not familiar with man pages, any kind of C library function, you'll be able to do a man on it, and you can get the man page, the manual page, and it'll tell you how to use the function. So you'll see here, file star, so it returns the file stream, and it takes a path, which we already have, current working directory already, so it's log, just the file name login, and the mode. Now the mode for us, it was R plus, open for reading and writing, and the stream's position at the beginning of the file. That's what we want. We want to be able to read and write it. And the mode string can also include the letter B, either as the last character or as a character between the characters in any of the two character strings described above. Basically that means it'll open it in binary mode. That's what we want. Let's just close this down. We're back here. Now you can do a check here, if FD is null, error open, return -1, whatever. Obviously, I mean, this is, I know what the file is, but it's just some error checking. So what happens is, let's say I made a typo there and I spelled the file wrong, or, if I don't have permission in the file, it'll won't open it, and it'll give you, it'll return null. So it'll tell me here, error opening. But as long as everything goes well, we'll have the file pointer open, and what we'll do is we're going to have to fseek. Now, what fseek does is, it actually will set your file pointer, so it'll set exactly where you're going to write to the file. So as an example, if you want to write 10 bytes into the file, you're going to go like this. So what that does is, so we want to fseek on this file pointer, so the one we just opened. We want to seek 10 bytes into it, and put the file pointer there. And we start off from this location, which is the beginning, 0. Now in this case though, we don't want to go 10 bytes in, we want to actually go to, we're actually not sure yet. We've got to find out what the offset is from GDB. And I'll show you how to get that. For now though, we're going to put in a default value. Define just the way to do it. It's just a constant. I'm going to put 0 for now. And then what we'll do is write it. So fwrite is file write. Then it'll write to the file for us. We're going to write our NOP, the address of our array, which is 2 bytes. Again, 2 NOPs. And it's going to be, they're 1 byte each, 2 members of it, of the array, and writing to this file pointer. Now, we can check the return values this as well. Fwrite returns how many bytes written, but it's getting a little long now, so let's just leave it like that. So real quickly, we have a character array with 2 bytes, 0x90 in each byte, which is, again, translates to a NOP, no operation assembly. We have our file pointer, which points to the login file, which we open for read and write binary. Then we're going to seek in that file to a file offset, which we will determine in a minute. Right now it's set to 0. And once we determine what that offset is, we're going to write 1 byte 2 times. So we're going to write this one and then this one, 2 NOPs, to this file pointer. Remember, we're going to write 2 NOPs because that conditional jump is 2 bytes. If you only write 1 byte, you're not going to line it properly, and the instruction will be garbled, and who knows what's going to end up happening, but it'll be undefined. You're going to end up crashing the program. So it's always going to be an equal byte swap. Yeah. So let's take a look here. Let's make sure it compiles. So let's see. It does. Good. Now I'm going to show you how to get the address. So first, let's get the address in GDB. So let's go to login. Again, same thing, break on fgets. Going to run it. Step out of it. Put in a password, doesn't matter. Disassemble. RIP. And we're going to see the address here. Now this is basically the virtual address as it's running in memory. So this address won't translate directly to the file. A little bit of math required to get that. So let's just copy it. 0x400678. Let me just copy it and quit. Let me make sure I copied it. I did. Okay. Now, all executable instructions are generally in the there's different sections that an ELF file has, a binary file has. Your code section is called .text. We've got to find the offset of the .text file and then do some math on that to actually figure out our hard offset of the file. We can use a program called readelf. I believe it's -s login. I'm going to grab up the .text. I'll show you real quick. So it finds the .text section. So again, the .text section, that's where your executable code is in the ELF file. When it runs, all your code will be in this, generally will be in this section. Now this section is mapped here. So what we're going to do is echo, we'll do some math here. So this is the address we got from GDB, our virtual address. We're going to subtract the actual address of the text section where it's located, which is 400510, and then add the size of it, 0x510. I'm just using little bash scripting here to actually do the calculation. Gives me 1656, that's a decimal number. Now, that should be the file offset of where that J&E call is on the actual file on disk. So now if we write that to that position on disk, our two knobs, we should patch it on disk. Let's check it out. 1656. So now I've got the offset. Let's recompile it. Let's run it. Let's run the login. Let's just make sure it's not cracked, hello, it's not cracked, access denied. Let's now patch it. I compiled it by default to 8.0. Let me just compile it so it's to patch, so I don't confuse you guys. Oops. Now I run our patch. Hopefully it works. Now it ran it. Now let's try login again. Let's enter anything. And now we're authorized. So now it's actually patched on disk. So now you don't have to go through GDB. It's not actually just a memory patch. It's actually a physical on disk patch. You move that login file wherever you want, and it's always going to be patched. It'll always be cracked. It'll always allow you access. So I'm not sure how long this tutorial is running. I think it's run too long now. I plan to do a part 3 tutorial. The next tutorial is going to include what I'm going to do is, because right now what we're doing is very, very basic. I'm going to actually make it a little harder. What we're going to do is we're going to do something called strip login. Basically what that does, it strips it of debug symbols, makes it a little harder. Most programs, especially under Linux that are released, they're going to have the debug symbol stripped, and you're not going to be able to put a break on fgets. It takes a little more knowledge to get through and how to crack it, but it's still pretty simple. We'll go through that for the next tutorial, which will hopefully be up soon. Thanks a lot. Have a good day.